Hey everyone, today we are gonna discuss about most important topic and the most misinterpreted topic of DSA. Actually, when honestly I was learning it in my classroom, I neither neither thought like this will be difficult. Is this topic difficult or is this topic easy? I was just astonished what the topic is, what the teacher is trying to deliver, or what the topic is trying to mean. There was wrinkle in my forehead, like what's going on here. But when I came home and tried to learn it by my own self, I realized that this topic is the not the most difficult one in DSA, but it is the most important, and it is the most linked topic. Like if you learn other data structures or other algorithms, data structures like arrays, strings, queues, etc, and algorithms like sorting, and some other kinds of cadence algorithm, many more, you will have to analyze their time and space complexities. So this was one of the reason of making my first video of DSA playlist on this topic, that it is the most linked one. If you try to understand it earlier, then after working on it, you will have a very good hands-on grip on the concept of big O notations. In this video, I will not directly throw formulas or definitions on you. I will try to explain what does these notations or time and space complexity means in real world. Now let us make understanding with an example, a real world example. Suppose either you have some on in your life, whenever somehow you have applied for any admissions online in any portal. Have you ever witnessed the website you were applying on, any school, college, or university website you have applied and for admission, but the website has been crashed, or it will be showing error page, and you other day you try, on the next day either you try to load it. What is the meaning of discussing it here is to make things relatable to you, making the concept relatable to you in terms of time and space complexity. Now what happens in the back end of this error is when I am not saying thousands or millions, when a large amount of users access one website at a time, the website can't bear the load of the that much users, or that much quantity of users, so the website crash. This means in future, while creating any new algorithm, any new app, any new web page or website, you have to keep in mind of its time and complexities. How you will check how if what if thousands or millions of users run your website at a time, will your website be able to hold the load? So this was a very I can say basic example, and start through example of time and complexity. Now if we discuss about some definitions in terms of time and complexity, so what does complexity means? The word complexity refers to dealing with complex things, or making complex concepts easier. Now we discuss time and space complexity. If we can say, like, firstly I have to ignore my writing on it, because I am just writing it with my mouse pad, and I think for me it is the best writing I can achieve. So first thing to discuss about is time versus space, where we should compare these both complexities. For in reference to this, the time complexity matters the more than the space. Why? Because we can add space, we can humanly or machinely we can insert, or we can say increase our space quantity or something, but the time is given by nature, provided by nature. We can't add more time, we have a fixed amount of time. So here the time complexity matters more than the space complexity. This is a genuine or basic reason of this. I am trying to explain you guys as much basic I can, so you can to make your understanding better. If still you are not getting the point, or having any kind of confusion in time and space complexity, be relaxed, be seated. By the end of the my laptops was sliding. By the end of the video, I promise you will have every concept. Firstly, I explained to you guys how why do we need time and space complexity by the example of the website crash. Secondly, we are discussing what are the complexities. Complexity means having some difficulties in somewhere in our algorithms. Not if we talk particularly about this topic, we are we means the complexities we are facing in on our algorithms or some sort of data structures. Now the thing is, time versus space complexity. As I stated, time complexity matters more than space complexity. I doesn't mean that space complexity is not important, it is nothing. We have to somewhere, we have to call space complexity, we have to check for space complexity, we have to give importance to it. But time complexity has more importance, because time complexity is not extended. We can't extend time, we can extend space somehow. Now how do we measure or how do we calculate time and space complexities? Now the thing to discuss here is, now we discuss complexities by mathematically by why it is drawing line by function f of n. Now n, what is n? N is the number of inputs, you can say. N is the number of inputs or the number of users trying to attempt something on your website, you can say. F of n is the number of inputs. Now if you have a given equation like this, if you are given an equation like this, for measuring its time and complexities, we will ignore the constant value, we will ignore the smaller value in power, we will take the largest available variable and take this as the f of n. The f of n should always be big number, because we are talking about the worst case, the large number, the complex number, we just mean by it. So here f of n is everything. F of n is n of cube, means the largest possible number present in the equation, and you will ignore all the rest of the equation. So this is how mathematically you look at the time and space complexity of it. Other thing, let me check out. I have created my notes and I check these so I don't miss anything. Now while referring with the complexities, we always have three scenarios, where one is best case, which is theta, one is average case, which is omega, and one is the worst case, which is where is the eraser? And one is the worst case W, which is big O. I don't know why. Yeah, I selected pencil by mistake. Okay, this is we have three cases: theta best case, omega average case, and big O worst case. We always consider worst case scenarios, but that doesn't mean the other two are less important. These all three are important. Now what can be the worst case, what can be the average case, what can be the best case of it? Suppose we are having a large number of array which has 1 million entities in it, or 1 million data structures in it. We are having an array of integers and we are having 1 million numbers in that array. So what will be, and we are finding one number in that 1 million numbered array. So what can be the best case? As you know, array indexes are measured by 0 to 1 million. Wait for a while. Array 0 to 1 million, And what can be the best case? What can be the best case? Our the number we are trying to find is on the first one, in on is on the zeroth index. As we started searching, firstly we find our number. What is the number? Or what can be the average case? The average case can be the number found in the middle while traversing, while going from 0 to 1 million numbers. We have found our number on the middle of 0 and 1 million. And what can be the worst case? The worst case can be we have found our number, the number we are looking for is placed on the last index, means we have to traverse till 1 million number till we reach till 1 million. So that can be very much time taken. The worst case can be very much time taking, and compared to this the average case can be the less time taken. And compared to both of them, the best case will have no time, it will have constant time. What the best case will have? It will have constant time. If you are creating notes, create it, write it down. The best case will have always have a constant time. I write great on mousepad. So, and the average case can somehow how can be equal to log of n or n or n square and much more. But the worst case can be 2 of n or something like 2 of n square or something like this. Now there is a chart I want to show you. I hope it is clear, or I will add its screenshot to the in the video while editing. So here is what you see will the input. There are cases, best to worst case, and in this chart we are seeing some important notations. O of 1 is the best case, which is constant. I forgot to write here. For constant we have the equation O of 1, and for nearest to the best case we have O of log n, which is the nearest to the best case. And after that we have O of n. After that we have O of n log n. N log n, if you identify, if you try to focus on it, what does this means? N dot log of n, log of n. So this means there is a difference between n and log of n, the best the nearest best case, and this has a difference that what should be the value of log of n will be multiplied to n for reaching this. So that's why this is more complex. This is more going towards worst case scenarios. After that we will have O of n square, means the number of inputs are doubled, are squared, of n cube, then O of 2n, and then O of exclamation, and this is all. Then if we consider these as the some common time complexities, now if we move forward, now for discussing how you will drive or how you will analyze the time and complexity of any question or any given algorithm, I want to share with you guys a question which I have solved in my exams. As I write it, you guys read it with me and try to solve by yourself. After it I will explain it to you guys. Now what the question says is, is a problem which is saying that we are given two procedures. Procedure P executes a pair of nested loops, both the outer and the inner loop, which iterates from 1 to n, and on each pass of the inner loop performs a constant time operation. And the procedure Q, each iteration, the procedure shrinks the remaining problem size to 1/3 of the previous size and performs a constant time check before moving to the next reduced input. Now, this explaining this problem, we can now what the problem is asking is, firstly we have to determine the tight asymptotic bonds and bounds, and after that we have to provide an approximate count of the basic operations carried by procedure P and Q, and we have to conclude the time complexity. Now what is happening here, the purpose behind choosing this question was to explain all the asymptotic bonds within this one question. So the procedure P is running a loop from 1 to n number of iterations, and there is one outer loop and there is one inner loop which is also performing 1 to n number iterations. This is inner one and this is the outer loop. Now what procedure P is saying, that we have constant n numbers, and in procedure Q this size is reduced to 1/3 on each iteration, 1/3 of the problem size on each iteration. Now how will you measure its time and space complexity? For measuring it, firstly focus on the question. What is saying? Procedure P is going from 1 to n, is performing n number of iterations, n time. Either it can be inner loop or for outer loop. So we can simply just drive n into n equals to n square, and we can write it here as O of n square. Remember one thing, for whenever we try to multiply, or we are going from one to another value, we are passing or iterating through or traversing through values, we will always take the time complexity as n, and if we have loops, we are having n, or we are having more than 2 loops, we are having 3 loops, their complexity will be always n square. And if the problem size is dividing, like in procedure Q, like as we come to procedure Q, our problem size is dividing to n upon 3 and 1/3, and if there is division, the size is reducing, then we will always take log of n. We will always take log. So this is a basic and simple logic behind this. You have to memorize it, that if you are iterating or traversing linearly, you will choose always complexity of n, and if you have loops, either it can be inner or outer, 2 loops or more than 2 loops, you will always take n square. And if the problem size is shrinking or dividing, if there is any division performing in your question, then you will always take complexity as log of n. So this was a simple answer for our question. That now for part A, we have derived the asymptotic bonds, we have derived the equations, and for part B, now this is asking that provide an approximate count and carried by procedure P and Q, and conclude which one has the best time complexity. Now according to the graph I have showed in earlier in my video, once again showing it, I hope it is clear and visible. The nearest to the best one, the nearest to the constant time complexity is O of log n, which is right here. So procedure Q has a best time and space complexity. Here procedure Q wins this. So that was a simple, I think I have made enough of your understanding on it. If you want some lead code or some important questions to be addressed, or simplify the lead code questions in the next video, and we should move in another part of time and space complexity, which will be of problem solving, comment down below, or you or any other topic you are having the difficulties of DSA. I will make sure on video, create a video on it, or otherwise we will move series wise, we will move linearly. The next topic we will be covering will be arrays. Thank you so much for listening it.